Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video on the distributive law. So the distributive law is what we use to help us expand brackets. So what we will do is start with an expression like this, 2 outside of x plus 3, and we'll end up with something that doesn't have brackets. So we call this process expanding the brackets, starting off with some brackets, ending up with something that doesn't have brackets. If we go the other way, where we start off with something that doesn't have brackets, end up with brackets, that's called factorizing. So we're going to do factorizing in subsequent lesson. Today we're just looking at going this way, starting off with brackets, ending up without brackets. So how did I get this answer from this? Well, that is obtained using the distributive law. Now, you've probably used the distributive law many times in mental calculations without even knowing it. So let's say that I had to calculate something like 18 times 104. So we're going to do this without a calculator. So many of you would have some methods for doing this, and I would say the most common would be to multiply 18 by 100, 18 by 4, and add them together. That's actually using the distributive law. What you're doing is writing this as 18 times 100 plus 4. Okay, so these two expressions give you the exact same answer because 104 is the same as 100 plus 4. So what you would do in your head is you'd go 18 times 100, 18 times 4, and then add your two answers together. So what you've essentially done from here to here, following this arrow, you have expanded the brackets using the distributive law. So we call it the distributive law because what we do is we distribute what's outside the brackets to both things. So we distribute the 18 to the 100 by timesing them together. That's how I got 18 times 100. And then I distribute the 18 to the 4 by timesing them together. And that's how I got this part here. So, of course, in this case, you have made it a lot easier. 18 times 100 is easy to do. 18 times 4, you just double it again, and you get an answer of 1872. The distributive law is very helpful for large calculations like this, ones involving large numbers. But mostly what we're going to focus on is algebraic expressions like this. This is just an example of how the distributive law works. You take the thing out the brackets, distribute it to the first thing, distribute it to the second thing, and then you're done. So let's look at some more examples like this. So how did I get my answer from 2 outside of x plus 3? Well, I just distributed the 2 to the x. 2 times x, we just write as 2x. And then I distributed the 2 to the 3. So 2 times 3, 2 times positive 3 is positive 6. So make sure you remember to distribute it to the second thing as well. People always forget that. The most common mistake I see is people write 2x plus 3. They'll do 2 times x, which is great, but they'll forget that they also need to times the 2 by the 3. So let's look at some more examples. Let's say I have something like 3 outside of x minus 7. So all I do is go 3 times x, and 3 times, in this case, it's not a positive 7, it's a negative 7. So 3 times negative 7, positive times a negative is a negative. So same thing for this third one. Distributive law, I go 4 times 2x, 4 times positive 5. It also works the same if I put negatives out the front like this. So this one's a bit tricky because of the negatives, but we're still going to follow the same process. We go minus 7 times 3, negative times positive is a negative, and then we go minus 7 times minus x. So because I'm multiplying a negative by a negative, the answer's positive. So this becomes positive 7x. All right, what if I have a pronumeral out the front, like a outside of 2 minus 5b? So it's the same idea, a times 2 and a times negative 5b. Now, if I have something like this, x outside of x minus 1, I'm going to follow the same process. But x times x we know is x squared. Remember, x plus x is 2x, x times x is x squared. And then, of course, I have to distribute the x here. I go x times minus 1, which is just minus x. All right, let's try one that's a bit harder. So this one's a bit harder because there are a lot of letters, but we're not going to do it any differently. We're going to go minus 3a times 2ab. So minus 3 times 2 is negative 6. Then I go a times a, and there's also a b. Then I go minus 3a times minus 4c. So a negative times a negative is always a positive. So it's positive 12ac, and then we're done. All right, now we're just going to look at some examples where you need to expand brackets and collect like terms. Please pause and copy these down if you need. So here we're going to expand and simplify what is on your screen here. Now, the most common mistake people make with questions like this is they add the 7 and the 3 first. They think it's 10 outside of 5 minus 2x. The problem with that is they're not following order of operations. So remember, if no operation's written, this is actually a times. I'm timesing 3 by what's in the brackets. So I need to do this first. I need to do the multiplication first. So I'm going to leave the 7 alone. 3 times 5, 3 times negative 2x. Now I'm going to collect like terms. Of course, 7 and 15 are like terms. And I'm left with this. How easy is that? So let's try this one here. Again, I've got 4x plus x times what's in the brackets. So I need to do the brackets first. I'm going to leave the 4x alone. So then x times x is x squared, and x times positive 2 is 2x. So this part I got using the distributive law. So now I need to collect like terms. So 4x and 2x are like terms. 4x plus 2x is 6x. We know how to add like terms. But x squared is not a like term with either of these. X squared and x are not like terms. So I'm just going to leave it as it is. The final answer here will be 6x plus x squared. So let's look at expanding and simplifying 10 minus x minus 3. A lot of people find this one confusing because they're like, wait a minute, there's nothing out the front here. So again, this is not 10 times what's in the bracket, it's 10 minus what's in the brackets. So I need to do this part here first. So note, the minus out the front is the same as if I made it minus 1. They're the exact same thing, just like x and 1x are the same thing. So to expand the brackets here, well, I'm going to leave the 10 by itself. I go minus 1 times x, minus 1 times minus 3. Remember, when you times something by minus 1, you only change its sign, not its value. So all we did was change the x to a negative and the minus 3 to a positive. Now we've done all the hard work, it's easy from here. 10 and 3 are like terms. 10 plus 3 is 13. Leave the minus x by itself, because it has no like terms. All right, let's look at a couple of examples where we're expanding more than one set of brackets. So let's look at this expression on your screen now. I'm going to expand this bracket, then expand that bracket and collect like terms. I do the brackets first because multiplication comes before the other operations, addition and subtraction. So let's start with this set of brackets here. So nothing different using the distributive law. 6 times 3x. 6 times negative 5. So now, make sure you understand this is not a 4, it's a minus 4. So I'm going minus 4 times 2, which is minus 8, and then minus 4 times minus x. Negative times a negative is a positive. So all the hard work's done, I just collect like terms. 18x plus 4x minus 30 minus 8. And I'm done. I can't simplify this expression any further. All right, let's do something similar here. It might look a bit more challenging because there's more than one letter now, an A and a B. Might look a bit more complicated, but we're not going to do it any differently. So we're going to start by expanding the first set of brackets here. So A times 2A, not 3A. A plus 2A is 3A. A times 2A, because we're timesing here, is 2A squared. Then I go A times minus 3. Now I'm going to do the second bracket. So I go 4 times b, of course, is just 4b, and it's positive. But then I go 4 times minus a is negative 4a. Now I've got to collect like terms again. 2a squared has no like terms. Remember, once again, a and a squared not like terms. So I'm going to leave the 2a squared as it is. Minus 3a and minus 4a, they're like terms. Minus 3a minus 4a is negative 7a. And then the 4b also has no like terms. So I'll leave it as it is, and I'm done. I can't simplify this any further. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.